Okay, now for section 1.2 on different types of data. So, as I may have mentioned before in section 1.1, if you have information from the whole population, that's called a parameter. If you have information from a sample, that's called statistic. So P population, P parameter. S for sample, S for statistic. So if you think about the average age of Hartnell College students, first of all, what do you think it is? Actually, it's 26.3. Which one of these is a statistic? In other words, which one is a sample? Well, when you use this symbol right here, which is the Greek letter mu, that stands for the whole population. So that would be out of the, I don't know, 13,000, 14,000 Hartnell College students, then the average age would be 26.3. So this is for the population, and X bar, that would be a sample. So if we went out and asked 50 Hartnell College students their age and found the average to be 26.3, we would be using the X bar. So which one is a statistic? That's the X bar. Now, when you collect data, there are two main types. Qualitative, and this is saying a quality. Quantitative, a quantity. So a quality could be, so for example, somebody's hair color. So it describes a quality. It could be their hair color, it could be their name, their gender, their political party. So these are all basically just names of different things. Political parties, those are names. Genders, those we use names. Names, we use names. Hair color, red, blue, purple, etc. So those are qualities. Now for quantitative data, we're talking about numerical data. And with numerical, there are two main types. Discrete data is something you can count. 1, 2, 3, 4, so you can count it. So for this example, this family has 2 parents and 4 children. So you could count the people. 1, 2, 3, 4, 5, 6. So it's countable. Continuous data is data that you can't count. You need to measure it. So for example, time, we measure it. Weight, you measure it. Height, we measure it. Now with the discrete data, the word discrete actually comes from if you have one person right here and one person right there, then there's not a person in between. There isn't such thing as here's the first person, here's the second person. We can't have a 1.7 person. But if you're talking about height, then you can measure it and get as accurate as you want. Now, most of the time we would say somebody's 5'10" or 5'11". That sounds discrete, but if you're more accurate, is it possible that somebody's between 5'10" and 5'11"? Yes. If you measure it accurately, they could be 67.833 inches tall. Even with the 67.883, is it possible that somebody could be 67.8831? Yes, maybe they just had a little growth spurt and now they're 67.8831. So a quick way to remember is discrete is if you can count it. Continuous is if you can measure it. Let's say that you're going to make a cake. You get out 2 eggs. Is that discrete or continuous? So we count the eggs. 1 egg, 2 eggs. That's discrete. And then you're going to put flour into the recipe. What about the amount of flour? Well, usually we measure it in 1 cup or 2 cups, stuff like that. But if you get a scale and you measure it in grams, then you could be using 67.833 or 883 grams of flour. So the eggs would be discrete, the flour would be continuous data. Next, levels of measurement. So we're going to start with the simplest and then work up from there. The way that I remember this is by using the word noir. N-O-I-R. It means black in French. So we start with the N, nominal. This is just names. So gender, the color of somebody's hair, their race or ethnicity. So there is no order here. So with the color of hair, I might want to say red-haired people go first, but there is no order. So that's nominal. Now we go up one level. Now these are things that can be put in order. So for example, grades, A, B, C, D, F. So there's an implied order. It's implied that an A is better than a B, and a B is better than a C, etc. But subtraction makes no sense. If I say an A minus a D, does that mean a B minus? No, it has no meaning, A minus D. So we've got N, we've got O, next should be I. Interval. So now these are things that, so we're building up, so you can still put them in order, but now subtraction makes sense. So for example, if you use years, the year 2014 minus the year 1990, that's 24 years in between them. But with years, there is no starting point. So you might say, well, if you go back to year 0, well, that's just the time of Christ. There was time before that, and there was time before that. So we don't have a year 0. So next up, let's see, N, O, I. Next is R, ratio. So basically this has the most amount of information possible. Not only could you put it in order, but you can also subtract, and it does have a natural 0. So for example, the distance between two objects. So if you have two objects, you could say you have these two, you find out the distance, and then you have these two and you find out the distance. If you subtract, it's going to give you this distance. So that has meaning. Could there be a distance of 0? Yep, right there. That's a distance of 0. So that is the ratio.